explicit definition is actually pretty easy for geometric series. It just tells us that a sub n is equal to a1 times r raised to the n minus 1, so it's an exponent, as long as n is greater than or equal to 1. Okay, so kind of like we did with finding a sub n for arithmetic, we just need to know two things. We need a1 and we need r. So we're starting off well because we know what a1 is. So what is our multiplying step here? Let's see. Look at my first pair, and I get 2. My next pair, and I get 2. This is a happy thing. My last pair, and I get 2. So r is equal to 2. I'll put it up here, r equals 2. Well then, a sub n is just a1, which is 2, times r, which is 2, raised to the n minus 1. And this isn't the greatest example of all because it's really, really important to recognize that the only thing that's raised to an exponent is this part right here. And we'll talk about that more when we do other examples. All right, so let's go back to our question. So now we want to find the 11th term. So if you remember, a sub n is equal to a1 times r raised to the n minus 1. So we need to find, since we know a1, we just need to find r. All right, so I'm going to do my first pair. Minus 32 over 64 is minus a half. 16 over minus 32 is also minus a half. So I'm feeling good about it. R is equal to minus a half. So for this particular sequence, a sub n equals a1, which is 64, times minus 1/2 raised to the n minus 1. So that's your formula. And it's just like with arithmetic, we're going to plug and chug. We want the 11th term, so n equals 11. So I'm going to plug a11 equals 64 times minus 1/2 raised to the 11 minus 1. So that's 64 times minus 1/2 raised to the 10th. So here's where it gets really important again to be really careful. The only thing raised to the 10th is the minus 1/2, and you have to do that first. I'm going to grab my calculator. So I want minus 0.5 raised to the half. It's going to be a pretty small number. Oh, that's raised to the 10th. Sorry about that, misspoke. All right, so minus 0.5 or minus a half raised to the 10th is a very tiny number. It's like 0.00097. It's rounded to 7. So then I multiply by 64. And I get another pretty small number here, but it's equal to 0.0625. So you can kind of see why calculators are going to be important here, and we're going to have to be really careful when using them. All right, I'm going to leave this to do together because it's a word problem. So we already talked about that because I had it slightly out of order. All right, so let's do a little bit more though, writing explicit formulas. So remember that a sub n equals a1 times r raised to the n minus 1. So plug an. So a sub n is equal to 12 times r is minus 1/3 raised to the n minus 1. And then this wants us to find the first 5 terms. So maybe we'll make ourselves a little table here. And it's 1, 2, 3, 4, and 5. All right, so a sub n is this. So the first time it's going to be a sub 1 is equal to 12 times minus 1/3 raised to the 1 minus 1 is a 0. A sub 2 is equal to 12 times minus 1/3 raised to the 2 minus 1 is 1. A sub 3 is going to be, and I really am kind of out of room here, so I think I'm just going to do the first 3 terms for you guys, and we'll do the others when we're together. I just don't like it. This is already, I think, a bit too crowded. So a sub 3 is equal to 12 times minus 1/3 raised to the 3 minus 1 is 2, so squared. So pretty much I'm going to put these into a calculator. I mean, I can actually do this in my head, but I think anything raised to the 0 is just 1. And so a1 is going to be 12. Anything raised to the 1 is just itself. And so this is going to be 12 times minus 1/3, which is minus 4. After that, we have 12 times minus 1 divided by 3 raised to the second power. So that was equal to 1.333 repeating. All right, we're going to leave the next one for you to do.